teddytalks.com. In this video, we are going to answer a numerical problem on projectile motion. Now, the question says that an object is projected upwards from a height of 60 meters high above the ground with a velocity 20 meters at 30 degrees to the horizontal. Another particle B is projected from the ground upwards towards A at 30 degrees to the horizontal. A and B collide at a height of 60 meters above the horizontal ground. When they are both moving downwards, find the speed of projection of B, the horizontal distance between the points of projection. Now, solution. For such a question, we need to first analyze it critically and then we draw a proper diagram that brings out the whole thing. They are saying an object is projected upwards from a height of 60 meters high. Now, assuming this is our horizontal ground, now, this is a height of 60 meters. Now they are saying the particle is projected from there at this height here. The particle is projected. But they are saying that at the same time, another particle B is projected. Now, the angle of projection of particle A was 30 degrees. Also, the angle of projection of particle B was 30 degrees to the horizontal. Now, we expect all these particles to move upwards and then finally come downwards. But they said that these particles collide at a point that is exactly 6 meters above the horizontal ground. So this has been the position of particle A, this is particle B. I mean A, and this is B. Particle A has an initial velocity of 20 meters per second. Particle B, we shall let its velocity be UB. We shall let this velocity be UB because it is what they want. Now, for A, so its initial velocity will be at 20 meters per second, and the angle of projection in both cases is 30 degrees. Now, the question is, how do we get a B? Question 2, it is saying that we should get the distance of separation between the two. Now, let us begin answering the question. Now we begin with answering Roman numeral 1. They are saying that an object A is projected upwards from a height 60 meters high above the ground with a velocity of 20 meters per second at 30 degrees to the horizontal. Another particle is projected from this side upwards to come that side, and then they collide here. Now, what comes to your mind here? One, for us to be in position to get the value of B, of UB, we must be having time because we have the vertical displacement as 60 meters. But now we have the 60 meters, we do not know the time taken by either of these particles to collide. So now our priority number 1 is going to be us finding the time taken for these particles to collide. Now let's say for particle B, for particle A, let's say they collide at point Z. For particle A, at Z, the vertical displacement is 0. And if we use our expression S is equal to U sine t minus a half gt squared, we can easily find the value of time here. So 0 is equal to 20 sine 30 times t minus 4.950 t squared. I've divided the value of g by 2. Okay? Now, what does this one show us? This one shows us that, let me first compute 20 sine 30 is 10. This is 10t is equal to 4.95 t squared. Now, we divide through by t and we realize that the value of t is 10 divided by 4.905. So 10 divided by 4.905, I get my time of flight, the time taken for these particles to collide, to be 2.04 seconds. Now, if that is the time taken, it means that it is also the same time that is taken by this particle to collide. So now, if I need its velocity, I also know it's at this particular time here, at this displacement here, we know the time which that body takes to get there. Now, if we know the time which this body takes to reach the point of collision, we can again use the second equation. Now we say that for particle B, at Z, its y is 60 meters. And the time it has taken to get there is 2.04 seconds. Now, from y is equal to u, b sine theta times t minus a half gt squared. Why am I using ub? It is the initial velocity of that body. Therefore, 60 is equal to ub sine 30 times 2.04 minus 4.05 times 0.4 squared. Now, this is 60. We know that sine 30 is a half. So this is equal to 0.5 UB times 2.04. This gives me 1.02 minus 4.905 times 2.04 squared. This also gives me 20.41. I collect my like terms. This one becomes 80.41 we divide it by 1.02, and our initial speed of projection of the other particle was 78.4 meters per second. That is it. It was 78.4 meters per second. That is the speed at which this particle must be sent off such that it collides with this other particle A at this point Z. Now, we have answered Roman numeral 1. Roman numeral 2 said the horizontal distance between the points of projection. Now, what is that horizontal distance? It is S1 plus S2, where S is standing for displacement here, that the distance is equal to S1 plus S2. Now, how can we get S1 and S2? The way, or the simplest way we can get S1 and S2 is using the equation of a trajectory. If we use an equation of a trajectory, we can easily get S1 and S2. Or if you don't want to use that, we still remember where we say that the horizontal range is equal to U cos theta times T. Therefore, S1 will be equal to the initial velocity, which was 20 cos 30 times the time taken to reach there, which is 2.04. Therefore, S1 is going to be equal to, I compute 20 cos 30 is equal to this value times 2.04. So S1 gives me 35.55 meters. Then S2 should be equal to UB cos theta times T. UB was found to be 78.4 cos 30 times 2.04. So I also compute this is 78.84 cos 30. Sorry, 78.84 cos 30 times 2.04. This also gives me S2 to be 139.29 meters. So the distance between their points of projection we said is S1 plus S2. So this will be 35.33 plus 139.29. So we add 35.33 plus my answer. I get my distance between the 2 points as 174.6 meters. Therefore, we have answered our question. Please recall that here we are saying the reason we are using the same time, since these particles are projected at the same time, it means at the point of collision they have all used the same time. The particles have used the same time. Therefore, we use this expression on this particle B to get its initial velocity. So our question is fully answered.